Whether it's drinking a glass of raw eggs or doing 100 push-ups by 4 a.m. every day, some athletes will do whatever it takes to get a competitive advantage. And some professional sports teams go to similar lengths to get the most from their athletes. That's why teams like the Atlanta Falcons and Seattle Mariners have revamped the lights in certain parts of their stadiums to optimize their players' performances. It's called bioadaptive lighting, and the idea is to use a certain kind of light to adjust the athlete's circadian rhythms to the time of day when they're at their best. But is this idea a home run or a swing and a miss? Many of us are familiar with the early afternoon slump, that time right after lunch where a nap is just calling your name and you're fighting for your life just to stay awake. But other times of day, you're a working machine, creativity, energy, and motivation galore. Well, just like the rest of us, professional athletes have certain times of day when they're at their peak. This Goldilocks time varies based on the person or the sport, but the consensus is that athletes are often at their best in the late afternoon and early evening hours. During that sweet spot, studies show that soccer players juggle better and score more goals, cyclists spike faster, and basketball players jump higher. So if we wanted to see athletes at their best, then every professional sporting event would be held at that time of day. But unfortunately, that's not how it works. And the key player here is the athlete's circadian rhythms. You've probably heard of circadian rhythms before, maybe in the context of jet lag or your late nights as a teen. It's the natural internal clock that all of us are built with. Even when we aren't aware of it, multiple systems in our bodies are operating under the guidance of this rhythm. For example, at night, your circadian rhythm tells your metabolism to slow down, which is why eating a huge meal right before bed can mess with your sleep and increase fat storage. And as weird as an abstract sense of time in your body sounds, it's very much real. In fact, there are a bunch of genes that code for this biological clock. Essentially, a bunch of our organs have this ticker, and a master clock in our brain exists to coordinate them all. And according to research, it's that clock that dictates what time we're at our best, including athletically. One easy way to see this is with traveling teams in the United States. Because the West Coast and East Coast are 3 time zones apart, a team's performance can be judged based on the time zone they're in versus the time their circadian rhythm thinks it is. And we can see patterns. A study from 2013 in the Journal of Sleep examined more than 4 decades of professional American football games, comparing the performance of teams from the West and East Coasts when they competed against each other. Daytime games, defined as starting at 1 p.m. and 4 p.m. Eastern Standard Time, were used as the control, while nighttime games, or those after 8 p.m. Eastern, were the focus of the study. They took into account the different abilities of the teams using a sports betting metric known as point spread, and checked how often the teams from the 2 coasts beat their odds to win. And they found that West Coast teams beat those odds significantly more than the East Coast teams did during the evening games. This makes sense for 2 reasons. First, when the games were played on the West Coast with an 8 p.m. start time, the East Coast team was at a severe disadvantage since their circadian rhythm was thinking it was 11 p.m. But that's just the start time. I don't know about you, but the only running I can do in the middle of the night is running out of energy. The other reason it makes sense that the West Coast teams did better is because when playing on the East Coast at 8 p.m., their internal clock is set to 5 p.m., which is close to their peak performance time. Either way, the West Coast teams had an advantage over the East Coast teams for any games later in the day. And there was a ton of data, so the statistical significance of this study was very high. For the stats folks out there, usually a p-value of less than 0.05 is statistically significant. This study had a p-value of less than 0.0001. Those are MVP numbers in this area of math. The researchers concluded that East Coast teams would benefit from delaying their circadian rhythm by about 3 hours, which gave some lighting companies and sports teams an idea. One major thing that we know affects our circadian rhythm is the amount and type of light we receive. So it's not a huge leap to think that we can use light to manipulate an athlete's circadian rhythm, ideally making those night games feel more like early evening games and getting to see everyone's top performance. Over the last decade, several teams have revamped the lights in their locker rooms and other team areas in the hopes of doing just that. The main difference between regular lights and the lights these companies use is that the new ones are tunable. Teams can adjust the intensity and temperature of the lights. Specifically, the new setups use blue-enriched lighting to suppress melatonin and mimic daylight before a game. Then, they can be adjusted to warmer, dimmer lights after a game to help stimulate melatonin and get players to sleep faster. But the big question is, does it actually work? And science says, maybe. It's kind of a three-part question. First, do circadian rhythms affect athletic performance? And the answer to that is yes. Research shows that circadian late afternoon and early evening are best. Second, can lights be used to retrain circadian rhythms? And third, if lights can retrain these rhythms, will that improve performance? To that second point, there's a bunch of data out there on how the circadian rhythm can be retrained with light. A lot of this research is on night shift workers, the people who keep the world running while the rest of us sleep. Using temperature and salivary levels of melatonin, researchers can track how light affects the circadian rhythm. Several studies have found that brighter lighting during the shift and a lack thereof on the drive home is able to delay or even flip night workers' circadian rhythms. And that comes with some perks. For example, when the circadian rhythm aligns with the night shift, workers report better sleep and mood. Plus, their performance is significantly better with these light adjustments too. So lighting is effective at shifting our circadian rhythms, and being in tune with your circadian rhythm can help your performance. But making that last link of retraining athletes' circadian rhythms with light and improving their performance is the hard part. So far, there haven't really been any formal studies on this new lighting in stadiums or how it affects players. The science of light suppressing melatonin and improving performance is there, but the research putting it all together isn't. The companies are mostly relying on the idea that blue-enriched lighting can increase alertness, but most of those studies weren't done on athletes. And the few that were had mixed results, finding that light exposure does decrease melatonin levels, but doesn't necessarily affect athletic performance. Plus, since the lights are adjustable with tons of different settings, they aren't easy to study outside of a lab setting. Still, a few teams have already spent a lot of money on bioadaptive lighting. And it's not just sports organizations. Schools and office buildings have too. Anecdotally, some claim that these lighting systems reduce headaches and improve performance, but again, there is no formal research supporting this. This practice kicked off a decade ago, so hopefully new research will shine a light on whether this actually helps teams win more games. But if your team is lousy, I wouldn't count on the light bulbs changing that. This video was inspired by The Inner Clock, a new book by Lynn Peoples. It's all about circadian rhythms and the surprising number of ways they affect our lives. If you'd like to check it out, head to the SciShow bookshop page. Thank you to the Alfred P. Sloan Foundation for making this video possible.